Hey everybody, I got some questions about the looping mountain terrain in this animation. So in this video, I'm going to show how that was done in a procedural way using geometry nodes. This takes some key concepts that you can find in other videos about how to do something like this and just builds on those concepts a little bit. And so yeah, I'll link to those other videos in the description for you so you can check those out if you want. So we're going to be building this node tree. And node trees can look pretty intimidating. So instead of trying to reverse engineer this whole thing, we're going to just rebuild this whole tree step by step so you can take it all in as we go. And it's going to help if you have some fundamental grasp or understanding of geometry nodes coming into this video, but it's not required. So I'll do my best to explain each node as I drop them in for those of you who might not be familiar with everything. So with that in mind, let's get to it. So I'm tempted to start right in with geometry nodes, but I think I want to just spend a few minutes describing a little bit of the, I guess, theory or mechanics of how this thing is going to work. And I think that's best described and shown with a material in the shader editor. So that's why we're in the shader editor right now. And yeah, so let's just spend a few minutes here. I just want to talk about a few things. So I'm just going to delete this principled BSDF and add a noise texture. This noise texture is kind of central to everything. It's going to be driving this whole thing. So this is a noise texture, and I'm going to add a texture coordinate node here. And I'm just going to hook up the UV output to that. So now we have our texture coordinates for our noise mapped from 0 to 1 in the X coordinate in the X direction, and 0 to 1 in the Y direction, and that'll be useful to know going forward. And our first order of business is to make this thing seamless. So I'm just going to duplicate this and move it over like that. And right away we can see that there's a seam here that we want to get rid of. And I'll just duplicate this in the Y direction as well. So we have these seams here that we want this to be seamless. So let's get rid of that first. And anytime we're considering things that are seamless or that we want to loop in a cyclic way, the secret sauce to that is the sine and cosine waves. So that's what we're going to use to create this seamless texture. And the reason why those are so useful is if you think back to trigonometry class or any class where you're dealing with a sine wave or unit circle, if you remember what that is, the waveform for the graph for sine wave is something like this. We have 0 to pi to 2 pi, 0 to 1 up here in the Y, and the sine wave looks something like that, right? So it's kind of like going like this, and then it just repeats right to infinity like that. And the cosine is similar, but it starts up here and it kind of goes like this, up like that. But the thing to note here is that this is cyclic, and we want to take advantage of the fact that it starts and ends at 0 over this wavelength of 2 pi, which is in radians. So let's just keep that in mind, just kind of take like a snapshot of that mentally. And what we're going to do is apply that to the mapping of our textures here. So the first thing I want to do is access those coordinates. So the first thing that we need to do is introduce a separate XYZ. This is one of the most handy, useful nodes in both the shader editor and the geometry node editor, which we'll see. I'm just going to drop that right in here. And you can see that we're only outputting X. That's why everything's looks like vertical streaks, but we'll just add a combine XYZ, the opposite of that, to bring everything back together in a vector shape so we can feed it back into the vector input of our noise texture. And we're just going to hook these all back in like this, so we're not really changing anything. So we've just split them apart and then we've combined them back together again. So nothing has changed here. We still have these seams to deal with, and that's what we're going to do now. So I'm going to add in a math node and right away change this to sine and just drop that in and remap our X coordinate texture with our sine wave. So that doesn't fix the seam. We're gonna deal with that in a second, but let's just look at our sine wave in isolation. And if you don't have Node Wrangler installed, just go to your preferences, click add-ons, type in Node, and then make sure that Node Wrangler is ticked there. We're going to be using that. And what that add-on enables us to do is hit Control-Shift-Click on a node, and we can isolate that and just view that node in the shader output. So you can see here that this doesn't loop, right? It goes from black to white and then snaps back to black really quickly again and goes to white, and it just kind of repeats like that. Why is it doing that? Well, if we go back to our sine wave, I should have left that up there the whole time. Let me just draw this back in. So we have our sine wave that looks like this. It's going back like that and coming around, back up to 2 pi, back up to 0 at 2 pi. And if we look over here, we have, let me just move these. Let me get rid of these first for now. Okay. So now over here, we have 0 to 1 and 0 to 1 for our texture mapping. And what's going on is we're only mapping our x coordinate across a distance of 1, which has only taken us about up to about here, right? Pi is 3.14, so 2 pi is about 6.28. So we've only gone this far. So we're only seeing our remapping going from 0 to, I don't know, just about 1 or near 1. So it looks something like this, right? So we're going like that, and then we're going back down again like this. So we're going from 0 to 1. Remember, 0 is black and white is 1. So that's why we're kind of getting this repeating pattern here. What we need to do is make this more like this, right? We need to make these loop a little bit more so these seams are the same. That's what we're going for here. So in order to do that, what we need to do is scale the texture coordinate to match the wavelength of the sine wave, which is 2 pi. So let's add in a vector math node. I'll drop that right in here before we separate them out. And I'm going to change this to scale. And watch what happens when I move this up. So we're going to move this number up, and I can see it, the whole wavelength kind of starting to come in. And right about here, oh, that's too far. Right about there is when they loop nicely. And you can see it's about 6.28, which happens to be 2 pi, which is also known as tau. And you can just type in tau there, and it'll precisely enter in that value. So now we should have something that loops. Let me add in another one here. This should be completely seamless now. So that's kind of what we're going for here. We're using the sine wave and the cosine wave to create seamless patterns. So we can just take this even further. So I'm going to just duplicate this, bring this down here, and I'm going to make this into cosine. I'm actually going to use the x output of that, feed that in there, and let's look at our noise texture again. So nothing is taking the correct shape quite yet, but I'm just going to I'm going to duplicate these and bring that down here. And I'm going to take in the Y coming out of our texture mapping, and I'm going to bring the sine into the Z like this. And our last, you can already see that it's noisy, but it's and it's looping, like it's seamless here. Like I don't see any seams here, but it's a little. You can kind of see some phasing here. It's not quite what we want. And the secret to solving that is using our 4D option for noise texture. So we have another dimension to manipulate, and we'll use this last cosine mapping coming out of our texture mapping here, and we'll feed that into the W value. And you can see that's going to make our noise texture look a lot better. So we can change the scale of this, and this should all loop pretty perfectly. I can add another one in the Y direction here just to show you that. So no seams here. So that's what we're going for. And we're going to use this concept over in the geometry nodes to change. We're working in 2 dimensions here, but we're going to use this to change Z values so we can have like a nice kind of variation in our terrain. So that's what we're going to do next. Okay, now we can get into the geometry nodes part of this and have some fun here. So what I'm going to do is just add in, it doesn't really matter what I add in. I guess I'll add another plane and drop a new geometry nodes modifier in here. So you can see that it's right here. And we'll just name this terrain loop or something like that. And this is what geometry nodes gives you to start. It gives you a geometry input, which is our object that I just added. And then it sends that out to the output. And there's going to be a whole bunch of stuff happening in here, which is what we're going to get into. So I don't really want this plane. I just needed it to add in the modifier. So I can just break this connection. We're just going to leave this group input rather, alone for now. And I'm going to add in my own cube node and hook that up to the output. So now I have a cube to work with. And I'm going to need some more subdivisions in here. Right now, there's just 2 vertices across in each direction. I need way more than that, especially in the XY plane, because this is what we're going to be displacing all these vertices up here to create some mountainous terrain. So I think for X and Y, let's just start with 64 size, 64 vertices. So 64 there. So you can see in the spreadsheet, it just dropped in a whole bunch more vertices there. And if I go into wireframe mode, I can see that the top and bottom are pretty sufficiently subdivided now. So that should work for us. And what we're going to be doing is modifying each of these vertices in this top face of this cube. We're going to be moving them all over the place using the noise texture to displace this face and create some kind of hilly or mountainous terrain. And then we're going to scroll that in the X direction later. So first, let's just use our set position node, another very useful node in geometry nodes. This is kind of the foundation for manipulating the vertices in any mesh for geometry nodes. So what we're going to be doing is using this Z value to shift up and down the vertices of that top face. But right now you can see it's changing the entire mesh. I don't want that. I just want the top. Just want this piece here. So we need to select just this top face or the vertices that make up that top face, and we're going to send those vertices into the selection input of the set position node. So how do we get at that? One way to do that is to check the normals of the vertices, and the normals are just it's a fancy word for a unit vector that points in the direction away from the vertex. So on this right face here, all the normals point in exactly in the y direction. So it's going to be 1, 0, 0. Those are going to be all those faces, all the faces in the face, all the vertices in the face nearest to us, like facing the camera. They're all going to be kind of pointing out that way. And on the top, they're all going to be pointing up straight up like this. So these are all going to be 0x, 0y, and then 1z. So we kind of want to check to see if the z is 1 here. And that should result in all these vertices being selected. The easiest way to do that is just to use a normal node. And this gives us access to all the normals of the vertices in a mesh. And we can get at the z component of those normals if we drop in a separate xyz and then provide it that normal vector. So now we can check to see if the z is indeed 1. And I mean, I guess there's a few ways to do this, but let's just use a math node and just use greater than 0 should work, greater than 0.5 should work fine. So the result coming out of this value output should be all the vertices that have a z component of their normals that are greater than 0.5. And the only vertices that those are going to be true for are these top ones. So if I then send in the output of that into the selection, if I've done this right, if I change z, it should only move the top vertices. So it looks like that worked fine. So I'm just going to select these and join those up, and then just name that something like selection top or something like that. Okay, so now we're ready to, I'm going to zero this out for now, but now we're ready to add some noise now into those vertices to change their Z values. So I'm just going to add a noise texture. And what I want to do is, I only want to change the Z. I don't want to change the X and Y. If I change those, it's just going to move this thing all over the place. So I just want the Z values affected. So I'm going to add in a combine XYZ and provide that output to the offset input. So right now, still nothing changes. I've just kind of blown out these different XYZ components so I can still change Z here like that. And I want to add in, the noise to the Z. So let me just undo that driver. Okay, so we're ready to do that. And let's see, so I should be able to add in the factor directly into the Z, right? Okay, so now you can see that let me just mute this so you can see what's going on. If I mute that and unmute it, you can see that it's adding some value between 0 and 1 to all these vertices. So some are going a lot, some are going a little, right? But they're all pushing up because they're all positive values. So it's going from somewhere between 0 and 1. So let me unmute this. And what I kind of want though is the top of this cube used to be about there, right? So it's kind of down there. And I kind of want the noise texture to be I kind of just want it to be clustered around here. So the general shape of this is still a cube. And to do that, easiest way to do that is just to decrease, I'm going to hit math here, math node, and then drop in a subtract math node. I'm just going to take 0.5 away from all the values that the noise texture is generating. So looks like that is kind of more what I want. Still kind of has the shape of a cube, and I can adjust this up and down if I want, but I'll just keep it 0.5. And lastly, what I can do is if I want to adjust this, like the magnitude of this noise, easiest way to do that is to drop in another math node here and set that to multiply. And if I multiply by 1, of course, it's not going to change anything. But if I kind of mess with this, I can make it more or less intense. And we can just call that, I'm just going to drop in a value node. And I can rename this something useful like intensity or something like that. Make that 1 by default, and then just drop that in there. So now we have kind of this nice sort of setup for the noise texture, and we'll just group this together and we'll join that up and call that noise generator or something like this. Okay. So this is our basic foundation for what we want to then loop and scroll, and that's what we'll do next. So next, let's make this thing seamless. So let me, let's duplicate this along the Y like that, so we can just kind of see where the seam is that we want to correct for. You know what, I'm going to take this intensity down a little bit. I'm going to add more vertices to the cube so I can just see a little bit better what's going on here, right? So, okay, we got this ugly seam right there. Doesn't match up. Here's where we're going to use some of what I showed you back when we were in the shader editor. Yeah, so let's add in a node called position. And this just gives us access to the mapping. I'm going to put that into the vector input of our noise. It doesn't change anything. It just gives us access in here. We can do things in here that relate to the mapping of the noise texture in these directions. So this is 0, right? This is 1. This is 1 up here. So we can access that and introduce our sine and cosine waves to make this thing loop nicely. So that's what we'll do next. So we're going to add in a combine XYZ node here, and also its opposite, which is separate XYZ in there. And I'm going to drop that in here and then bring that back. So we have, I'm going to hook this all up again. Okay, so nothing changed. We just are giving ourselves access to the XYZ components of each of these, each of the vector mapping. And so next we're going to be using those sine and cosine waves. So let's bring those back in. Let's have a sine wave. I'm just going to drop that in here. I'm just going to use the same setup that we had gone through in the shader editor. So I'm just going to quickly reproduce that here. I'm going to use cosine here to mix it up a little bit. We're going to feed that into X. And let's get rid of Z for now. And let's duplicate both of these. We're going to send the Y now into these two sine and cosine waves. And I'm going to feed that into Z. And you can see we're almost getting back to what we had before. And now, if you remember, we are only mapping sine. It's not going enough of, it's not covering enough distance. It's only going to 1. We need to go from 0 all the way to 2 pi. So that's what's going to give us the looping. It's just like one wavelength across this cube. Let's add a vector. No, that's not what I want. I want a vector math node. We'll add that in here, and then we'll set this to scale. This should feel familiar to what we were doing in the shader editor. So right now it's 1, but you can see as we scale up, we're giving our sine and cosine waves more distance to play with, and we need this to go all the way to 2 pi, if you remember. So 2 times pi, or you can just type in tau if you want. So this is very spiky and hard to see that it doesn't loop. So let's bring this scale down a bit here. So now you can see here that what used to be a gnarly seam has just completely gone away, and now it's nice and smooth. So that's what we want. So the key to all that is making sure that we scale our mapping to 2 pi, so that the sine and cosine waves map exactly to one kind of wavelength of that function. Okay, I'm going to take this one out and just focus on one of our cubes here. So how does this whole thing scroll? We can do that by manipulating the X component of our vector mapping. And so to do that, we need another vector math node. I'm just going to drop that in here. And we'll keep it on add, because we're just going to be adding values to the X, which is this first input here. So if I just drag this around, you can see that the whole thing just kind of moves and moves and moves. So that's what we're going to be doing to create this sort of scrolling effect. And we want to do this over the course of this timeline. I have it set to 100 frames. I mean, you can kind of set it to what you want, but 100 seems good. So what I want to have happen is I want this texture to move. So if we're just look at this one vertex here, I kind of want it to move one unit away by the time this playhead gets to frame 100. So to do that, there's a handy node in geometry nodes called scene time. And that gives us access to the frame number that we're on, which is what we're interested in using. And I want this vector to go from 0 to this x component of our position vector to go from 0 to 1 over this time period. So from 0 at frame 1 to 1 at frame 100. So to do that, what I need to do is drop in another math node and divide the frame by the total number, the current frame by the total number of frames that we have. So we get a fraction from 0 to 1. So this is going to be 0.5 in here and so forth. So that's what's going to give us that. And if I need to combine XYZ node, because this wants a vector shape, so that's going to map into that. And I'm going to feed now this fraction, like this, the output of this socket's going to be something between 0 and 1 as we go across the timeline here. So I'm just going to drop that right into X. So now if we drag our playhead, this should just now go from 0. Just going to play it for you. So it should be going from 0 to 1. And when it resets back to 0, we don't notice it because remember, this is perfectly seamless. So we set that all, that's why all this work was done beforehand. Now, if you want, you can change the scale of the noise over here, but make sure that you do it on the noise texture itself, not this scale here, because this needs to be 2π for this all to work. So make sure that that's left alone, but you can change the scale to whatever you'd like, and of course the intensity or whatever it is that you're going for. Now, what if you wanted this to go faster or slower? There's a couple ways to do that. One is to increase the frame count here. So we could make this, say, 200. And then remember, I'm going to have to also update that. So we're getting this 0 to 1 fraction out of that. And you can see now it's moving super slow. And that's okay, but it's kind of a pain to adjust the frame count all the time to get the effect you want. So I'm just going to bring that back to 100. And actually, while we're at it, let me just drag this out and provide a value there. And we're going to call that value frame count and make it 100, just so kind of like to keep things a little bit organized. Okay, so yeah, so what's another way to make this thing move, or to create a control to adjust the speed of that? One of the ways is to add another math node. I'm just going to duplicate this one. I'm going to change that to multiply. We're just going to multiply the speed by some value called, I guess we can just call it speed. So we'll keep that 1 for now, but I'll show you how this works in a second. But right now, all we've done is taking this fraction from 0 to 1 and multiplied it by 1. So we're not doing anything yet, so it should be the same. But once I move this up, things get faster or slower, right? So if I made this really big, it's going to get super fast. But also, you notice that there's a problem. If I make this whole numbers, 0, 1, 2, then the looping is fine. But if I make this like 1.4 or something, watch what happens when we get to frame 100. It just kind of like, it skips, because now we've sort of broken this nice looping setup that we have. So that I'm going to bring this back down to 1. How do we fix that problem? We're going to have to go back to our scaling here, and I'm going to pull this. Actually, before I do that, I'm going to add another math node. Set that to divide, and we're going to have to divide 2π or tau. So we're going to have to divide this value by our speed, which will provide that in a second, but I'm just going to hook this up for now. Shouldn't change anything, so we're just dividing tau by 1. And let's just verify that we haven't broken anything. Okay, so what we need to do is divide tau by whatever we're updating the speed to. So now if we make it 2, you can see that it's still looping. Like if I get rid of this, it's still looping nicely. But now and 1.4, let's just make sure that works. That still works, but now we've got a new problem that if we make this speed faster, it's almost like you're zooming in on the texture, so it's starting to flatten out. Whereas at 1, we get a nice variation in our texture, but the faster we go, it's almost like you're zooming in and not actually moving it faster. So we need to fix that. And to do that, we need to pull off our scale here. So I'm just going to bring this over here, and I'm going to add a math node. And I want to divide, I want to multiply this. I'm going to multiply that by, let's just add in a new controller, new value. We'll call that scale. Make that 1. And we're going to have to multiply that scale by the speed that we're changing. So now we've got that being provided into, I'm just going to reroute this a little bit here. So now we're providing that scale to adjust for our speed. So now if I increase our speed a little bit, it's going faster, but now also our scale is still being kind of adjusted, so it's not getting that super zoomed in look. So that's kind of what we want. And we can adjust the scale here to like that. Make this 2, make this 4.4, whatever we want. So everything should be compensated for now. Gonna bring these back to 1. Maybe make this 0.5. Let's make the intensity maybe a little bit more or less. I don't know, whatever. It's up to you at this point. So now we've got a nice looping terrain. In this process, you might have noticed this. In this process, what we've lost, I'm going to duplicate this over again, and over here, you might notice that we've lost the seamless aspect of this if we change the speed to anything other than 1. You can regress back to an earlier state of this tree that we're building if that's important to you, if you want to multiply these textures. But in the animation that I made, I just wanted that 1 cube, so I wasn't really concerned with having more of these. So I just needed the 1 like this. So I wasn't really concerned about that. So I would rather just have the ability to adjust speed than have multiple instances of this be seamless, but that's up to you. So anyway, let's bring this back to 1. So we've got pretty much the basics set up. And what I want to do now is add a little bit of variation to this thing. I kind of want like a valley in here, and I want this valley to be kind of adjusting the overall terrain, and then I want kind of like a lake bed in here to look like there's sort of like lakes or maybe even a river flowing through this canyon. That's kind of what I want. So that's what we'll do next. And again, there's probably more than 1 or 2 ways to do this, but the way I did it, I'll show you, is with some of this stuff out of the way here. I did it with a wave texture. So I'm going to add that in, wave texture. And we're going to be building another kind of generator here right near this noise generator. And we're going to combine these in later down the tree. But let's just create the wave generator. And this thing is going to be outputting something that it's going to look kind of like that. And we're going to be adding that to these Z values. And hopefully we'll come up with something that that kind of has this effect on the overall shape of this thing. So let's add in a math node, and we're going to be adding the output of the noise to, let's just add 0 for now, right? Because we're going to be adding and subtracting values to each of these vertices on top to create this wave. So let's just see what happens right off the bat. So let's put in this factor here. So that's nowhere near what we want, but this is easy to change. We can change the scale down to something like that, but that's kind of not really the right direction. We need to go in, we need this to be going in that direction. So let's just change the X to Y. There we go. And that's super intense. So let's maybe just change this intensity here a little bit like that. Maybe even less than this. And I kind of want this, I don't want this canyon directly in the middle. I kind of want it to be maybe offset a little bit. So we can offset the phase a little bit like this, and maybe just make the scale something like that, where I can see kind of the tops or the crests of the canyon. And detail scale. Okay, That's kind of what I want, but this is super deep. I want this to be not that intense. And so the way to correct for that is a math node multiply by something less than 1, right? So we can kind of just calm things down a little bit, maybe something like that. And then maybe a little bit more offset, something like this. Okay. I think I'm happy. With that. And then lastly, what I want to do is I kind of want a floor to this canyon. I don't want this to go all the way deep in there. I just kind of want like a lake bed or something in there. So I want to, let's look from the front. So I kind of want to introduce a minimum value that this valley can drop down into. And an easy way to do that is after we add the z's together here, we can create another node over here, and there's a handy thing called I think it's called minimum. You know what? It's not in the math node. I'm going to get rid of this. I think it's just a separate node called clamp. Yeah. So I'm going to clamp these values, and you can already see it's having an effect here. So the min is 1, and I can raise that to wherever I want. The max, I should just make that clearly like up here somewhere so nothing even touches that. Because if I bring this down, it's going to max out at something like that. I don't really want that, so I'm just going to keep that like 2. So the min is really what I'm interested most in. So I can continue to kind of tweak that to what I like, and I think maybe something like this is cool. So it's like maybe something a little less. Yeah, that looks good to me. So that's how we get the floor in there to create kind of like a lake bed to this valley. So again, we can still increase the speed and kind of adjust this stuff to what we want. Maybe not that high, something like this. And we can still play with our intensity of the overall texture and strength of this thing. We can add detail. We can distort it. We can do anything we want. This is all procedural, so this is what makes this so powerful. And you can even make something that looks like, if I take this, in fact, I can even just mute this thing to take that whole valley effect away. And if I keep the intensity up a little bit and bring the min up, I can kind of create something like this cool effect where maybe it's like a different planet or something, or some kind of like I don't know, alien sort of thing, or something even weirder. But there's a lot of things you can do now with this, or maybe even like islands that are passing by, whatever you want. So that's kind of the power of this of geometry nodes for procedural scrolling textures, and you can do all kinds of things with it. And I'm going to stop here, but if let me know if this format of video works for you, if you learned a lot doing this or watching this video. And if you want, what I didn't do is texture this. That's a whole nother thing. If you're super into this and you want to take it the rest of the way and see how I did that, let me know in the comments or just drop me a note, and I'll think about like a part 2 to this video. So yeah, just let me know. And thanks for watching.